To the cloud. Take it away, Josh.
Sounds good. It looks like Joe, we've got your yield results up here. Um,
As of about 11:50 last night, I finally broke through the software impasse.
oh wow, great. Um, so do you have the opportunity to look at that one field that we sampled? Just kind of to give an overview. So with Joe, we did the organics. There was replicated strips. So we had organics treated, and then we had untreated, and it was in replicated strips. We pulled rhizosphere samples. So we went out and we actually took the crop, which was probably around V1 and or V2, and we bagged it, brought it back to the lab. We also pulled soil samples for greenhouse testing. And so what we'll go ahead and do is we're going to go over Keenan's going to go over some of the greenhouse results that we had for Joe Rose field, and then also we're gonna go through the infield data and then see how this is kind of stacking up with what Joe saw out in the field. Were you able to make some sense, Joe, with some of this data?
Yeah, this is very preliminary. So just the nutshell here is you're seeing the whole field in the little photo there, but you really can't zoom in enough to probably tell. There's a little building site there, and you see the strips north of that building site. Those are the replicated strips there, and I selected 4 passes with organics, and then I still have 4 passes that have never had organics, and this would be the 3rd year on that farm for using organics. And those 3 strips have never had it, or those 4 passes have never had it in that time. So this is a total of the 4 strips are half-mile strips. And something I think I'm seeing there, so I plant 16 rows and harvest 8. So I think when I was selecting my pass, as it went through the double layers of data, that's why you see basically double the acres on the planting layer, because it selected that full 40-foot width, but then it selected whichever corresponding 20-foot pass on the grain harvest side that was underneath that. So that's why I think if I was seeing that last night, our acres were about half for the harvested versus a planted. So like I say, very rough, extremely rough. And the other thing I want to caution is with the wet spring, I have tile lines there that are running north and south. So there's certain areas of the field where it didn't matter what you did. If you're on the tile line or off the tile line, that was all your yield difference. But this particular area, I think there's enough relative comparisons that weren't affected by waterfall and the tile disproportionately. So, and across, 4 half-mile replicates that are on a little different space in the tile line, I think we're getting enough of that randomness in there as well, or out of there, I guess, to maybe start drawing some conclusions.
Awesome.
So hopefully that's somewhat clear as to the craziness.
Well, it's a lot of data, so I know it takes some time to go through it all, but thank you. Appreciate you for sharing some of that. Do you know, I guess, roundabout, were you able to pull yield from just that area that we sampled? If that's something that you have.
We can. I do not have that right now.
Okay.
But we can, and that's something where the team probably will be able to pull in closer, right around that sample area.
Okay. Excellent. Well, we'll go ahead and kind of go over our results. Keenan, do you have maybe we start out with the infield data, if you don't mind walking through the infield data, and then we'll do the rise score on that, and then we'll do the rise score on the greenhouse.
Sure. Yeah. I can actually I might just pull them both up at the same time. I got them both up right now. All right, so lots of data to look at here. Don't let your eyes glaze over yet. I know it's early. On the left, this is going to be our greenhouse sample for Joe Rouse Field, and then the right are the samples that we took in the field this year. And I guess that was June, I think, when Josh and I were out there. And so ran the exact same tests on it. Both of these were comparing the untreated areas to the that have never had organics over, I think, 3 years, and versus the ones that were treated. And there's a couple interesting takeaways from this, right? That we do see a response in both cases. So that's one of the most, I think, exciting things, for that Josh and I saw was we saw consistency, whether we're testing it in the greenhouse under controlled conditions or out in the field, we're seeing the results correlate, right? They may not be exactly the same, and we can talk about what some of those differences were and what to maybe expect. Based on a greenhouse trial, what you're going to see in the field and kind of how to think about those differences. But I'm going to dive in a little bit because we saw really good response in the field. This on the right is going to be the in-field trial. About a 0.36, which is a pretty big response, and 4.2 to 4.6 rise scores. These are pretty reasonably healthy. That's kind of this rise score is just a way to sum up and kind of try to make a single number make some sense out of all this, all these numbers and data we have here. I'm not sure if everyone has seen this data before, so I'll drop in just a little bit that these are percents, basically, is the way to think of all these data. They go from 0 to 100, and what, say, this 51.1 means here is that we saw more genera of organisms, more categories of organisms in this sample than in 51.1% of the samples in our reference population when we took about 600 samples that we reference against. So as you go down, just kind of keep that in mind that these are going to be comparing to all the other samples that we've taken in the past. As we go down, there's a couple big takeaways that I always love seeing really high mycorrhizae and fungal to bacterial ratio. So love seeing that in the field. Kudos, thumbs up to Joe, I think, for that one. That's always a good sign. But one of the kind of interesting takeaways that I have from this sample is we see this rise score go up, but actually the number of genera that we see goes down a little bit. And this isn't necessarily uncommon in the rhizospheres that we test, the roots that we test, because the plant is going to be selecting for certain microbes. It's kind of recruiting the ones that it wants and leaving out the ones that it doesn't need. So even though we see this drop here, we see such big gains in our nitrogen cycling pathways down here and our phosphorus and polymer degradation pathways here that the score goes up considerably overall, right? And so that's obviously one of the big things that every farmer is looking for is, am I going to be able to fix more nitrogen, right? Am I going to have, better phosphorus availability in the soil? Is the fertilizer that I put down, is that going to be converted into forms that the plant can take up? And this is pretty easy to say that this product helped improve the plant's ability to take up some of those nutrients or to cycle those nutrients based on the genes that we were able to identify. And so even though the number of microbes went down, those were basically better microbes. They're all microbes that are going to be serving functions for the plant. And I guess unless anyone or Josh or Lauren have any questions on the infield, I can kind of bounce over to the greenhouse sample, which showed kind of a similar response, right? We see a little bit of a reduction in the observed genera, smaller than the infield. We still see pretty high levels of mycorrhizae and fungal bacterial ratio, but not quite as good, right? Those are going to be more well established in the soil in the field than once we chop that soil up and bring it into a greenhouse and try and grow something in it again. But we do see improvements. We see nitrification goes up, basically about the same nitrogen fixation. So we're seeing less of a functional improvement in the greenhouse, and that's why this rise response number is a little bit lower compared to the field where we saw this really significant functional improvement. Part of that is probably just due to the age of these crops. When we take these greenhouse samples, they're not super old. They're only going to be a couple weeks old, maybe a V2 if anything. And so they're not cycling quite as many nutrients as the infield crops will at a little later stage. but it's enough that we can sort of see the direction things are going. And based on the fact that we see a positive response in both cases, the plants are doing a little bit better or quite a bit better even when they've been treated versus when they weren't treated. I guess I don't need to dive too much deeper for now. We can always kind of answer questions specifically. Where do you want to take it next, Josh? You guys have any questions on this data?
Yeah, well, I do want to say, and the reason why I wanted to check in on Joe's yield, we've seen something really interesting happen with this data as we're continuing to pull rise scores on greenhouse samples more specifically. I think what we're seeing is that we're able to, if we see a response, say it's 0.1, typically we see a 6 to 5 or 3 to 5, 3 to 6 bushel change out in the field, specifically on greenhouse samples. And so far that trend has held true, which is really amazing. And so we want to make sure that we're continuing to, if we continue to see that trend, that's a really strong indicator that that early forming crop is an indicator of future yield. The DNA that is in that crop has a strong correlation to the genetic potential of that soil and of that crop to produce yield, which quite honestly is I think it's a groundbreaking discovery. Because if we are able to find those bugs that are associated with producing high yields or whatever it may be, or growth in the field at the end of the season, that means that we have a predictive test that can tell y'all what the performance of your soil is going to be before you put a seed in the soil. I know that that's a pretty big claim, but we're going to be really looking at this yield data closely and seeing if we continue to see that trend. So far with the folks that have gotten back to us with yield, if there was a response, there was a positive, there was an observed positive response in the field. And I would say that well, if we go over and maybe we can jump into some of the greenhouse data. We ran 50 different soils this year in the greenhouse, and all of that data, not everyone's soil and seed responded. But I would definitely say more than most. So more than 50% of the soil responded to compost tea. And so we're hoping to continue to get yield data back so that we can see that trend continue as we're getting this information. So you want to do you want to jump in, Keenan, into the maybe some of the summary data that we have?
Sure thing. So yeah, this is one of our greenhouse trial data, basically, and this is a real eye glazer. There's a ton of data here. This is going to be basically our treated and untreated for in the greenhouse for all those different metrics that we were looking at on this data. So basically doing this same comparison just in a big table form so we can compile all the data from all the 50 trials or 50 soils that we did this test on. Like Josh mentioned, you can kind of see here this row is going to be the response, basically, if it had a positive or negative response overall to treatment. And you can see that most of these did, right? We see a lot of green here. Some of them pretty small, but some of them are pretty big increases, 0.8s and 0.6s that we would expect in the field to lead to a noticeable improvement in plant health and potentially in yield as well, as Josh was saying. So just in general, really kind of like to see this here. And I actually don't mind seeing that some of these didn't go up, right? Because then we can kind of ask the question, what is the difference between a couple of these two fields that makes this one go way up, and this one actually went down a little bit with treatment, right? And that's when we went through and we took the pH, we looked at soil texture and water holding capacity for all of these soils in our lab. That kind of helps us inform on some of those differences. And as Josh was saying, we're going through and we're collecting some kind of metadata, just data about the, people's practices, their management techniques, and yield data for as many farms as we can. That also kind of helps us fill in those gaps and try to figure out, is this product working better on conventional systems versus strip till no-till systems? Is this working better in cover crop systems versus, corn on corn systems? And so this is some of those data points here and yield data that we're still filling out. Obviously, we're can't ask for yield before people get a chance to harvest. So we're still kind of trying to fill this out, and I think this will be something that we'll be reaching out to some of everyone on the call over the next few weeks or whatever as we fill this out. But what this does is it allows us to, and forgive the Christmas colors here, but anything green is going to be a positive response, and anything red is going to be something that responded negatively. And what we did is we sorted by the different crop types and the different soil, pHs or soil textures or management techniques. And what this kind of allows us to do is to say, for example, here, soy actually went up a little bit across the board, averaging all the different soybeans that we did, went up a little bit, whereas corn actually went down a little bit. So this is telling us that maybe it's not a huge difference, but this product works slightly better on beans than it does on corn. And we can even see that, some of these metrics have real differences, right? Pretty significant. Same with pH. We can see that it performed a little bit better on low pH soils than it did on soils above about 6.5 or 7.5. Did pretty well across different soil textures. The only reason, or the only one it didn't, was silty clay and silty clay loams, and we don't have a lot of those samples, so it could just be a little bit of kind of what we call noise in the data. Things just vary. It's not always, not everything has a reason. Sometimes the numbers just change. But this is one of our kind of what we're really excited about, is because we are seeing some interesting differences here, right? This cover cropping one is a good example. You can see kind of all the red versus all the green. And this indicates that based on the data we have so far, systems where farmers were implementing cover cropping responded better to this biological treatment than systems that didn't. And we're still kind of, filling in this data. So this is provisional, right? It's subject to change a little bit, but this, these are the kind of results that I think we were hoping to get. And typically we do see that, if a farmer has been implementing conservation practices for a number of years, for a real long time, they actually might not respond too well to treatment, right? The biology in the soil is already getting pretty healthy and not needing much of a boost. But one of the things we see here is that, yeah, if you're cover cropping or if you're doing reduced tillage, there's probably still some room for improvement, unless you have a field that's been no-till for 20 years and hasn't had any, or really has reduced inputs or something like that. There's always going to be room for improvement, and that maybe even some of those techniques that allow that biology to continue growing over the off season or to be a little bit less disturbed actually leave it in a good place, that once you go put a product on, that less disturbed soil might really be able to kind of take up that biology and run with it and perform functions that are going to help the crop. Again, these right here are an example of some of those nitrogen fixation and phosphorus cycling. So these are kind of key metrics that I always like to highlight, that most farmers seem interested in, is, am I adding nitrogen to my soil, and how am I, liberating phosphorus from rock forms? And so we do see some good data here, some interesting improvements in certain areas and losses in other areas, right? This is a good example that we didn't see improved nutrient cycling in high pH soils. And so we could dive a little deeper and farm by farm to kind of try and figure out why that might be, if there are other factors that are in there, but it's always interesting to look at this. And so just to kind of lead in, this is where we're taking some of this data, and why I think Josh and I will be reaching out over the next however long to kind of try and fill in a few more of these practices from some of y'all, so that we can, make this a little stronger and be able to draw some of these kind of conclusions about how different soils respond to treatment.
I have some extra yield data points that aren't in that sheets. It's kind of I'll drop that to you, but it's really fun. I like to figure out. I've got a little yield calculator on my computer. It's a work in progress, but I've been pretty close sometimes, which is crazy. We're having fun. So this data is really interesting and something that we're really excited about. And the way that I like to think about the RIZE score is it's the genetic potential of the soil to you know, I don't want to say produce yield, but produce life in the soil. So if you can establish a benchmark wherein we know that X, Y, or Z products will have a response for your specific soil, then that's a huge win, because we can say we can help y'all to be able to match up different seeds or different biology for your specific soil just based off of the genetics and the microbes that are available in the soil, if that makes sense. So that's one of the things that this study has begun to highlight for us is indicated that these signatures that are in the soil, they're really, really informative. And so we still have a lot more data to collect, but so far it looks pretty promising.
Yeah,
Do y'all have any
definitely.
questions? Do we want to, maybe we could go over, we have everyone's in-field data. Hey, kid.
I was gonna say, if you could go over each individual one, and that way if they watch the recording, they'll be ready for when we do the one-on-ones.
Okay.
To kind of have a little insight. Like Dan's on here already.
Oh, very good.
Who else do we have on that? Yeah, I know you did. But if you could go through individual ones when they watch the video, that'll help them be ready to do the one-on-ones with you, I would think.
Yeah.
Excellent.
And we're ready to schedule those too. So if anyone wants to schedule a time to meet with us to kind of go in more detail on the results, we're happy to do that. We'll be sending out an email here shortly just to kind of get those scheduled. Keenan, do you have Dan's results?
I was just pulling up Dan's. We'll start
Okay.
there.
That's good. And we ran, remind me, did we run infield and then also greenhouse?
Yeah. So yeah, let's do you want to run through this infield real quick, and I'll pull up the greenhouse sample.
Yeah. That works. Okay, so we have home fields, and then we have high OM and old pasture. Looks like the home field performed pretty good. We had, for all of these observed genera, it's right around the 40 range, so no major changes there. A little bit higher on the high OM. Then we have community evenness. One thing I like to point out on this community evenness score, you often see that it's very low. That's not necessarily, one thing to keep in mind is that we're pulling and referencing this data to soil from the Midwest, but these are rhizosphere samples. So in the rhizosphere or the root zone, there are not typically a whole lot, there are not as many microbes in those systems compared to like a soil system. Those microbes, they're very active, and sometimes the crop, they recruit specific microbes that serve certain functions that the crop needs at that point in time. And so don't be worried whenever you see that community evenness score low for these root samples. We're continuing to update that information, and we have enough data at this point to be able to have reference these soils against all the other soils to get better averages here. But then we have mycorrhizae, it looks like home field kind of knocked it out of the park there with the number of mycorrhizae that we're observing. We have really strong fungal to bacteria ratio in the home field. And I think because of those two reasons right there, we had a really strong response below, especially with nitrification, and then we have a little bit lower denitrification, which is good. We're not losing as much nitrogen for home field, and nitrogen fixation is through the roof. That's really high, which is awesome to see. I'm looking at home field right here, and then phosphorus cycling is high. Polymer degradation is the soil's ability to break down complex carbohydrates. So if you have compost or manure out in the field, this is the marker that you want to look at to see if we're breaking down some of the carbon that's just sitting out in the field. Drought resistance those are microbes that have the ability to create biofilm, which essentially is they're able to secure and hold more moisture in that soil, in that system. There's the crop produces a lot of different hormones, and so we'd like to observe that in the drought resistance score. And then we have disturbance there at the bottom. So low disturbance is an indicator that you don't have tillage, or that you don't have major compaction and things of that nature. So kind of going through here, some of the things that kind of jump out to me is that we have a little bit more denitrification occurring in the high organic matter and the old pasture. That could just be because we still have some compost or manure that's still out in the field. And so what typically happens is that a lot of those systems, they don't have as much oxygen, and so you have a little bit more. It could also be that we sampled during a time of the year when it's wet. So denitrification occurs typically whenever there is a lot of water, or if there's maybe still manure that hasn't fully digested yet out in the field.
Yeah, I was going to throw out that just these are all really high scores. I don't know if Josh really kind of hammered on that, but these are great. and you really do see that in these 3 nitrogen cycling values here, and then the phosphorus cycling and polymer degradation. Those are really good, really strong nutrient cycling across the board in these samples. And there are some definite differences in genera and like the fungal bacterial ratio that kind of lead to the differences in the scores, but across the board, really like what we saw here. And yeah, I'm just pulling up, apologies,
Yeah, the fungal to bacteria is what stood out in my mind. Do we know why the difference was there? If Dan can jump on, or might have a little hard time unmuting himself. I don't know if I can figure out to help that from here. Ask to unmute.
There, I think I got it now.
There you go. Morning, Dan.
Yeah.
Morning, Dan.
Yeah, I was hoping my son was able to get on. He must be having trouble, and he would understand this. He'd love it. You've got it recorded, so hopefully I can.
Would that be Michael or?
Yes, Mike. Yeah.
Yeah,
he
he's on here,
stuff.
so.
Oh, yes. Oh, hopefully he was on. He's having trouble at the beginning, so.
Yeah, I know he was on before we started this one, so I think
Okay,
he's
good.
unmuted now.
Good. That's good.
Can you hear us, Michael?
Yeah. Well, we'll see. Repeat your question again.
Are you able to explain the differences between the fungal to bacterial ratio on the home field versus the high OOM and the old pasture?
I would think soil type maybe a little bit. The home farm is just I call it my lighter soil because it's under 5%. Where a lot of well, I guess the old pasture is quite high too. I think there's 6, 7, even 8% organic matter in it too.
Mm.
Yeah, so that, might be it. Where the home farm, I actually have like 3.5% organic matter. It's higher
Okay.
ground. It's much higher ground. I don't know.
I would throw out, didn't mean to interrupt you, Dan, but we did do our kind of lab testing and we saw pretty, home field had a pH of just over 6.0 and the high OM field had a pH of about 6.8.
Okay,
So we are seeing some pH differences that certainly could be at play in there. And then
Okay.
yeah, some difference in soil types. The high OM field was a lot clayier, had a lot higher water holding capacity, which I guess tracks if, like you're saying, there was, maybe 8%, 7, 8% or something OM in there.
Yeah,
Yeah, could definitely be feeding that ratio.
yeah. I don't know. I'm learning this. That's very interesting. That's for sure.
What would you say, Dan, is typically your better performing field? I know that we pulled from, looks like 3 different fields.
I would say that over the years, the home field, that's usually what the farm that I use for test plots, because it's quite consistent, the whole farm. And, where there may be a little more variant in the other farm that's only half a mile away, but,
Mhm.
One thing I wanted to drop and also mention here, we just expanded our fungal reference database, which is the number of different fungi that we're picking up on, tenfold. And so it could be that there are other fungi that previously we didn't pick up on for some of these other pastures. That will, I don't know if it was tenfold, I think it was 100-fold. So we have
A big
many,
difference.
many more fungi that we're looking at. And so I'd love to see what that, if we're able to maintain these fungal to bacteria ratios with this new report that we have as well.
Constantly improving some of our processes behind the curtain, right? To kind of try and really tighten this data up and make it really actionable for you guys. So
if Michael is on, do you know down in the left-hand corner that microphone disappears? Turn it on. Maybe he's got a comment. He knows this farm very well, See if he has anything. Maybe he can't find that mic. It's pretty hard here. You got to get it to come up off the top. Mike, are you there? Well, he won't listen to his dad, I guess. I don't no, he's probably struggling with it.
I'm here.
Yeah.
I would
Hey,
agree with you. It's maybe soil type. The home farm back in the day, maybe you hauled a little bit more manure on it, but outside of that, I'd really not a whole lot of differences.
okay.
do we have any data on the greenhouse? Is this a greenhouse samples?
These
Keenan,
are
or-
the 3 infield samples, and let me pull up the greenhouse samples. I got those ready.
So we're running compost tea and we're running algae right now on these soils. So we're continuing to throw more things at the samples as we receive them from input manufacturers. And so as we continue to
Sorry, one sec.
get more data, we're gonna update y'all to see if if there are any good candidates, potential candidates for biologicals that might work well in your field.
This is the greenhouse data, same format. This is we're gonna have both the home field and the high OM sample. We ran our greenhouse trial on both. And this is gonna be a good example that unfortunately we didn't see positive responses here. And this is something that like kind of I mentioned that if you have really high scores to start with, there's a better chance that you're not necessarily going to see a positive response, that these really high nutrient cycling values and some of the stuff like that we saw in the infield, or really high mycorrhizae, all that sort of stuff, makes it hard to improve. There's just not a lot of room to improve. And so these were samples where we actually didn't see a positive response in the greenhouse. We still see, things look pretty similar in general. Again, a little bit less well-developed microbiome in the greenhouse. That's kind of typical. We tend to see that partly just again because of the age of the plant. I think the infield crops that we pull were probably V5, maybe V4 to V6. And obviously the greenhouse plants are much younger, so the scores are going to be a little lower. But we see some slight decreases of observed genera. Again, there's a lot of microbes in these soils. They've been well built up with that kind of high element stuff over time. And you see that with rare biosphere as well, really high in the untreated soils, a little bit lower in the treated soils. And so the nutrient cycling stays pretty comparable. I guess we see a little boost in nitrogen fixation here, but not enough to kind of overcome some of the losses that we had in observed genera and stuff. So we still see a negative response, even though, yeah, a few, I would say nitrogen fixation, that's the real improvement, a little bit more mycorrhizae. But again, slightly less diverse.
Have you, I know, Dan, you love to do trials. Have you trialed any compost teas? Is it on the home field more specifically in the past?
No. Mike had texted me something after on my phone. One thing different about that, I'm going back to that former question you asked me. That home farm was continuous corn for like 10 years. And that's different than the other farms. So that was one different. He thought of that after we talked. Okay, go back to your other question then. The current question.
So wanted to ask if you've ran any compost teas. I think you answered my question on that.
Yes. No, I haven't. I've messed around with just small strips of comparing different biologicals and stuff like that. Not. Actually, it wasn't even on the home farm there, but it was on a farm that neither one of these are on. But no, I've just played around with little strips.
Okay.
Dan and Michael, would you be able to share your yield data with Josh then? And then if we can start jumping to some of the other farms, if you could bring up Whittleson for me, that's what I can help you out with before I'd have to jump here. So
okay.
Yeah, give me one sec. We didn't do an infield for Whittleson.
Yeah, Whittleson's the one I pulled samples. I think Ross would be one he pulled him himself. Schaefer Ridgeway, you guys pulled.
Yep.
Josh Jeske, you guys pulled.
We got Fox. We got Carl Fox.
Yeah, Carl Fox would be, if like I said, I'm gonna let it keep recording. If you guys can just kind of give a brief overview of each one, so when they watch it, they'll be a little more prepared when you do your one-on-one call and make the best use of your time for that.
Yep. Here, like, I'll pull up Fox since I thought that was the one I was going to jump into next.
Like I said, I got about 10 minutes. I got to jump on. Well, I'm going to help your North Carolina friends out here I asked late last night if I would help out some North Carolina farmers. So
Very good.
Um,
Let me just, Josh, you mind if I'll pull up, maybe I'll pull up Carl Fox's and you can run through that and then I'll finish, pulling up Weddleson. I gotta locate something real quick. Sorry about that.
yeah, Carl Fox would be one you guys pulled. That was in the storm.
Yeah, that was a fun one, actually. We got to, yeah, get a little wet and muddy out there.
so Keenan, you're wanting me to pull up which samples?
Oh,
Carl
I
Fox.
can pull it up real quick. Sorry, my computer's being a little slow. Got too many documents open.
Yeah, I know Sam Ziegler will be watching the video here, so if you can get his kind of preview. Clark's will be watching.
Yeah, here is, I don't know if you guys, hopefully you can
Yep.
see my screen. Yeah, this is Carl's infield response. Again, this was these were really two different fields. The response, I don't know if it kind of quite applies here. It wasn't like a treated, untreated. But there was one that was kind of his favorite soils out there, and then one that was, or he had recently applied Pivot Bio to. And so we do see some interesting results. This good soil that he's putting his manure down consistently on had really high observed genera, really high mycorrhizae, good rare biosphere. Actually, the fungal bacterial ratio was a little lower. I guess maybe that kind of makes sense that there's, some of those little saltier, hotter nutrients in the manure, it just is never perfectly digested. That's promoting bacterial activity. But you also see some good stuff in as you would hope from Pivot Bio, nitrogen fixation is off the charts here, basically. And so both really good scores overall, 5.5, 5.9. Josh, did you have anything
Yeah,
else that you see there?
yeah, I think so just to kind of give you some background. So Pivot Bio, they sell a 2 species nitrogen fixer. So it's really, really strong at fixing nitrogen. One thing that we do notice though is that typically with a powerful microbe, you oftentimes get a little bit less competition in the community evenness. So community evenness is essentially a metric of how many do we have a lot of diversity? Are there a lot of microbes that are competing for resources? Or do you have one or two or three dominating species that are, I don't want to say taking over that environment, but really they really establish a strong population, which is what we're seeing here with this sample as well. I know it doesn't seem like a lot, but 2.5 versus a 3.6. It's substantial enough to say that looks like it's around a 30% reduction in the amount of other microbes that are servicing that crop. And so typically, if you have less community evenness, that means that some of these other functions might suffer as a result.
Oh, this is Doug. Sorry I'm late. I just want to note with the nitrogen fixation, there's very it's hard to know, like in this case, what the baseline was there, since this field looks like obviously with a good manure, it's already very high, right? So it's hard to know what contribution Pivot Bio is having here.
That's a good point.
And then I think, as I had mentioned before, you know, if there was a recent manure application, and the manure is not fully digested, we often see higher denitrification occur in those systems, which is what we're seeing here. At least there's no major change between pivot bio field and then good soil manure. I'm not sure if Carl had applied manure to that other field as well, but this is that's the typical response that we see with denitrification. Denitrification is converting nitrate into NH4 gas, which is it's a loss of nitrogen. Sometimes it's an indicator, though, that nitrogen cycle is just really working really well. And so, you know, though you have a loss of nitrogen, you know, you still are fixing and you're still converting a lot of the ammonium that's in the soil or the organic nitrogen that's in the soil into something that's plant available. So.
Keenan, was there another one we wanted to look at?
Keenan, you're muted.
Sorry, yeah, I will bring up Wedelson real quick. Stop sharing.
Yeah,
And-
this should have been tilled versus no tilled.
Yeah.
Yep,
the
and this
biggest
was a
cover
good one. I
crop.
think we did see kind of an interesting difference here between the till and the no till.
Yeah,
So
basically conventional versus regen. This one should be. How's that?
that works great too.
Dan, did you happen to get the yield data? I know it's kind of still close to after harvest, but we'd love to, if you have that data available, we'd love to learn a little bit more.
Yeah, if we don't have Michael's email to you, I'll send try to get an email with you, Michael and Dan, so we can get the one-on-one set up for as soon as possible. Michael would have the data from what I know.
Yes, we'll get it to you. He'll have to find those exact spots on his maps and get what it yielded in those spots.
Very good. So if you guys see me again, this is going to be, I think it's Blake Wedelson's field, and we have both the till and the no till. Again, some really nice, healthy soils. Kudos to all you guys out there. These really, there's been a lot of really healthy looking soils come through. We did see again this kind of typical loss in observed genera. Again, that's not the end of the world in a rhizosphere, because that might just mean that the crop is selecting for the ones that it wants more than the ones that it doesn't need. Not a huge change, I would say, in this sample, but overall, partly because of this loss in observed genera, we do see a slightly negative rice response. We still see really high nitrogen cycling, good phosphorus cycling, good polymer breakdown, but a little bit less complex and competitive microbial community in the till sample. And this is for the greenhouse. We didn't get any infield samples here. Whereas
Yeah,
in the no
the treated
till
would be
sample,
the tilled then.
what's that?
The treated is the tilled versus untilled.
So we had two soils. We had a till and a no-till soil, and so we ran the treated, untreated on both of them to see how each one would
Okay.
respond to the treatment. And this was a kind of a cool response that the no-till had a slightly positive response versus the till. And so this was kind of an interesting one that, even though we had some good biology, it still stood a little bit of room to improvement, or maybe that the microbes in that no-till system were a little bit more adaptable for whatever reason. We're able to kind of integrate the introduced biology a little bit more effectively than the microbes in the till system that might be a little bit more stressed. because yeah, it's not a huge difference. You know, it's only a 0.1 response versus a minus 0.2, but it is, you know, a positive
Okay.
versus a negative. We did see an improvement in the
It is
no-till soil.
two different. Can you go back to the other one then?
Yeah.
There we go.
Katie, did we run these from infield?
Oh, these are greenhouse results.
Oh,
We did
oh,
not get
oh, I see.
infield rises.
Yeah,
for these.
this would be one that I pulled the samples as Ross Crush would be, Rick Clark's would be, and then I'm trying to think, was there another one? So I'm kind of curious. Do you see a difference between the ones we pulled versus the ones you pulled? That's the main reason I wanted to bring this one up while I'm on yet. So
Oh, that's actually a good question. Let me, maybe for that, I'll just pull up this kind of whole sheet. Give you guys a little
like I
peek
said,
behind the
that
curtain a
might
little
help
bit.
you guys figure out sampling protocol and all that.
Yeah, absolutely. Yeah, just take a look at this response column here. Oops. Kind of see what the overall response was versus the farm. So let's see. Yeah, Clark's didn't respond. Um, Ross Koresh had a really nice response actually. Both fields saw a good positive response. Mitchell's field split, right? So one of the areas, let me see which one that was. So the treated area versus the untreated area out in the field, actually the treated area responded a little bit better to treatment in the greenhouse. I apologize, Lauren. What was the other one you want? Ziegler
Uh,
did.
what was the other one?
Well, the
You hit Clark's was no response. Ross Crush was good response.
Yep. Rush had a really nice response.
And like
What the
Rick Clark's, that would be long term regen. Ross Cross is kind of just getting into it.
Yep.
Mitchell would kind of be well into it. I'm just trying to help tie in common denominators for you. So
Yeah, definitely. Um, oh, Josh Jeske, we saw some interesting ones. This is kind of I know there was one field that had a terminated cover crop and one that the cover crop was not terminated, and we saw a pretty significant difference between those. The area that the cover crop had already been terminated actually responded a lot better. It had a little bit lower score to start with, responded a lot better, and if I remember right, we saw a very similar thing at the Beaver Creek field for Jacob Bolson that
yep.
there was a terminated and an unterminated, and the soils where the termination had already taken place had a better response. And I think that could be related to a number of things. Maybe that biological community takes a little hit. It always is going to take a little hit, whether no matter what you're burning down with, whether it's glyphosate or your fire, you know, it's always going to take a little hit. And maybe there's more room for improvement in those soils once it's been terminated versus if it's unterminated and you got a cover crop in there, it's still pretty healthy. There's not going to be much that those introduced microbes can do. You know, and actually, now that I think about it, I believe Sam Ziegler's field saw, oh, actually, that was a little bit of a different one. And this one, the cover crop actually did quite well, responded really well versus the home field, which I think had a few week old soybean crop and it had a good layer of manure put down. And so again, maybe had some well digested manure, already put a bunch of biology down, maybe not that much room for improvement. So there are always kind of some lessons I think that can be learned from these, and almost across the board we saw at least some sort of interesting difference between the each farmer's two samples, like something, whether it was a management technique or which sample responded. There's almost always something interesting to be taken out of that. Let's see, we have Nate Moretz. What's his other sample?
and Josh Jeske, I spoke with him yesterday. His if you could scroll to the left there. Do you have the rise scores? Where are the rise scores for these two?
Untreated were 4.4 and 4.1.
Yeah, the untreated area, there was about I think it was a 40 bushel change. So that one area that we had a good rise score on performed better, based off of our conversation yesterday, which is good.
Very good to know. Let's see. Oh, Olson. That's another. Sorry, it's been a while since I was out there. I'm trying to remember who all was part of this, the ambulance part of the trial. Olson was an interesting one because there was a no-till and a till field there.
Not see you.
And in this case, yeah, the no-till field actually didn't see as good of a response versus the till field. If I remember correctly, that no-till field had been no-till for a long time, over a decade, something like that. And the till field they had just rented out from a neighbor for like a year ago. I don't even know if it had a full season on it yet. So again, we're kind of, looking at small changes, but it is interesting to note that a field that has more well-established biology maybe doesn't have quite as much room to improve, whereas a pretty similar field, only a mile or two down the road, but that has been tilled pretty hard and traditional chemical regime for a long time, it did have a little bit more room to improve, and has a little bit lower rise score to kind of begin with at a 3.6. So that's I think was a good result, kind of tracks with what we would hope to see or what we would expect to see there. Oh, Schaefer was this soil was a tough one. It didn't really move the needle that much either direction, kind of minus 0.01. A good high rise score to start with, over 5, so like seeing that. But yeah, didn't necessarily move the needle too much either way. I'm not sure if, I think the functional attributes were really pretty high to start with, so there wasn't a lot of room for improvement there. Oh, there's the other.
Yeah, Schaefer would have been the vegetable farm.
Yeah, I think there was peas and there was some a handful of some root crops and stuff out there. So
Yeah, hi. And it looks like we've got Catherine on, maybe not on screen, but there. Hi, Catherine.
Any questions from the crowd yet? Before I'll be watching, but I got to focus on this other call. Like I said, appreciate this, Josh and Keenan and Doug.
Yeah.
If you want to just kind of give a preview yet to each one that we haven't touched on, I'd appreciate that. Otherwise, that way we get ready for the one-on-one calls with them. They'll have a little bit of insight what to look for and be thinking about. So appreciate it.
yeah,
Thank you.
Yeah.
I appreciate
Thanks,
it. Thank you for your time.
Yeah, and I'll get the recording out as soon as I get it back from the cloud to everybody. So I think we got some good stuff captured here.
awesome.
All right.
So I guess I can jump into some of the infield trial results if that works. We do have a handful more, and I think for Mitchell, for Nathan Moretz, for Olson, and for Ziegler. So we can kind of throw those up and run through those real quick, and then can point out any more greenhouse results that you haven't gotten to yet. Let's see, make sure my screen is working right. So this was Mitchell Horacefield. I don't know why my formatting isn't working here. My computer's working pretty hard this morning. But yeah, no real significant difference. And so this was actually looking infield. They had applied a product. I can't remember exactly what it was, some sort of like a fungicide type product.
It was a
To-
Growmark natural fungicide.
And so this was a cool result to just kind of see it. It did maybe make some impact on a few of the metrics. The observed general went down a little bit, but you actually saw some gains in some of the nutrient cycling and no significant losses. And some other ones, fungal bacterial ratio stayed real high, didn't impact mycorrhizae too heavily. So this would be, I think, a pretty good response for that, if you're putting down a fungicide or an herbicide or something, you're really just hoping that the score doesn't go down a bunch, right? It's not going to improve, but if you can, treat the potential for pathogen pressure and at the same time not impact your microbial community too heavily, I would call that a win. So that was a result that I thought was a good one. And again, some nice high rise scores to start with. Let me pull up Moretz next.
Got Ryan Gibbs on the call. I know that we ran a greenhouse study for Ryan. I guess this was earlier this year, or really maybe in January or maybe late last year.
It was early this year, like January, February. I wanna
Okay.
say.
Yeah. How did things turn out for you?
So, well, we had fields that broke all-time records, like highest yield average across fields, and then we had a field that had the all-time worst field average. So it depended
all over
on
the place.
depended on what type of soil it was.
Yeah.
With all the rain we had this spring, we had a lot of just anaerobic soil, and that some of that ground was, ground that we just picked up renting here in the last year or two. So it's been pretty well degraded, and so we're trying to rebuild. So with yours, I ran the mycorrhiza product, just some BioK Plus, which has got endomycorrhizal and ectomycorrhizal fungi in it. I don't know, the yield was, that farm had the second highest yield we've ever got off that. So, and that was 220 bushel average across that field, which is pretty good considering we had about 4 acres of that 80-acre field that was almost a zero from deer and coon damage. So if we could have got 260 bushel off of them 4 acres like we did the rest of it, it would have been a lot better average. But 4 acres of zeros was it was tough to swallow. We got some pretty ugly looking yield maps where everything's green and then all of a sudden we got huge spots of red. So, but no, I thought the data was really helpful this last year, and trying to feed kids and take care of kids here too.
Were you able to do any replicate, or were you able to do a check strip for that mycorrhizae?
Yes. So basically I was running it in furrow. Let's see here. And basically I have it on my basically what I did was I took a picture of the, hold on here, I'm trying to bring it up in my pictures so I can read it off to you guys. What I did was I took a picture of my yield monitor and then I just reset it and renamed it. So we have, I just called it starter versus no starter is what I called it.
Got it.
So corn on corn, no starter, 200 and let's see, 10 be 14, 216 bushel, and corn on corn with starter was 220. So you're looking at a 4 bushel yield increase there.
And you did it with the mix, right?
Yes, with the mix. So it was mycorrhiza fungi with a orthophosphate starter, 945-15, so it doesn't have any salt in it. It had micronutrients in it, and then I did put a little bit of molasses, like a pound of molasses, an ounce of yucca, and an ounce of fulvic acid, just to feed the biology. I just wanted some biological food.
Yeah.
And then we move over here and we do so it was 32,000 plants per acre. This was corn on beans, same field. A yield of, so no starter was 259 bushel.
Oh my.
and with starter was 269 bushel. So
Oh
it's
my
10 bushel.
gosh.
So it's 10 bushel difference there between the two. So every place I put the starter paid for itself.
That's great.
And when I look at my in-furrow program, my entire in-furrow program cost me less than like $11 an acre.
Oh wow.
So the 945.15 is like $5.50 an acre, and then $1 for the fulvic and $1 for the yucca, and the mycorrhiza product was like another $1.50. Molasses is like 25 cents. So when you look at it, my whole in-furrow program, it's a lot of stuff in it, but it's pretty cheap because I'm mixing it all myself. I got the labor in mixing it, but even at a 4 bushel yield increase at $4 a bushel, $16 an acre. So, we did see a positive ROI on that. And I got these pictures of this if you want it.
That would be wonderful. I mean, so I guess going back to the work that we did in the greenhouse, so we actually mixed the yucca, I know that you sent in may have been some Johnson Sioux compost.
Yep.
We did molasses, which is what you see here. So this is the mix.
Yep.
And then this is the untreated, which we reviewed.
Yeah, there you go. You got it up on the screen there now. Trying to do split screen on my phone. It's kind of small, so yeah.
Yeah, I can zoom in a little bit,
Yep.
but
no, you're good. I can zoom in on my end here too. So
it looks like so with the untreated, we're looking at 216 and 259. Our total score, rise score, was 4.3. And then whenever you had the treated or the mix, we saw a 0.2 change. Typically we see a 3 to 5 bushel change for every 0.1 increase in the rise score, which is confirming this statement right here, which is you saw a 10 bushel change.
Yep.
And then we had a 4 bushel change here with that other field. So it's kind of cool.
Yeah, and we made some mistakes. I know we did a lot of things right this year, and there was a couple things we didn't do right. We got kind of rushed because we had a 3-day soil event at our farm and another field day at our farm this summer. So we were kind of rushed to get our side dressing done before that. And that was a very costly mistake. We should have side dressed later instead of earlier. But it just is what it is.
Yeah. We did a 2x2 in the greenhouse where we tried to replicate a 2x2. Is that correct? Yeah.
Yep. And that's what I do. I run 2x2 on the planter.
Okay.
And
awesome.
then I come back and side dress, typically according to what my soil tests say. We'll pull soil test at V3, V4, so we can be side dressing by V5, V6. And we basically side dress based off the soil test. Because some fields get manure, some fields don't. Some fields are corn on corn, some fields are corn on beans, some fields are corn on cereal rye multi-species mix, the previous year. So every field's different, and every field gets a different program. But I know we side dressed too early this year. We did back off quite a bit on our nitrogen, maybe a little bit more than what we should have. We need to be stair stepping a little bit slower, I think, on especially this rented ground.
Okay.
So.
Yeah. Well, great work. That's some pretty incredible yield responses you got there.
Yeah, like I said, I'm gonna put this basically all on a spreadsheet because
Hey Ryan, you're muted.
There we go. Well, for some reason, hold on, can you hear me? Can you hear me now? For some reason, it went on to safe driving mode. Let me hit leave. No, I don't want to leave the meeting. Well, I'll just leave it at that. Let me go back to my picture here. So I did, we did high population. So it would have been a 38,000 population compared to my typical 32,000. And the yield actually went down 4 bushel per acre. So 38,000 was 255 bushel versus actually it was more than 10, it was almost 20. So next to it at 32,000, hold on, Kendrick. Next to it at 32,000 was 269. So
What were the two treatments there?
it was the same in furrow on both.
Okay.
It was just a population. The difference between 32,000 and 38,000 plants per acre.
Okay.
So, and then we did no-till versus strip-till. We only seen a 1 bushel yield advantage on strip-till. So on both replicated trials, it was a 1 bushel yield increase with strip-till. So I was really hoping to see more, but the biggest problem I faced this spring where I strip-tilled is where I had weeds right next to the corn. Where we no-tilled, there wasn't any weeds by the corn. So just disturbing that soil there. I'd kind of like to move to a different strip-till bar, but I don't know. The no-till's been working pretty good. My stand was good. But we'll see. Just throwing
Have you
around some
tried,
different things.
yeah, have you tried any like roll crimpers or there's a cool product. It's curse buster. Have you heard
Yeah,
of
my
it?
neighbor's got a curse buster. I have been kind of looking at those actually, just to poke holes in the ground to get the soil to breathe better, especially on my soils that have high magnesium that are just tighter soils.
Yeah.
We are putting down BioCal, which has calcium sulfate in it, because we're trying to raise our calcium levels, and because our calcium levels are low anyways. So we're trying to raise our calcium levels and still get enough sulfur out there to help bring our magnesium down. But yes, the curse buster is, I think, a pretty cool tool. Just basically pokes holes in the ground so the soil can breathe.
Okay. Well, we have a company that we're working with that has a it's like an insect byproduct which is high in chitosan.
Okay.
And I'm assuming I'm not sure if that corresponds with calcium. Could Keenan, could you ring in here? Do you know if chitosan plays a role in or insects byproduct plays any role in calcium?
It doesn't, as far as I know, it doesn't play a role in calcium.
Okay.
The chitosan is a natural fungicide, insecticide, biocide, whatever you want to call it. I know a lot of guys have had really good luck with it, and Beck Seed Corn is actually putting it as an optional seed treatment on their soybeans as a natural insecticide, fungicide, bactericide. Yeah. And so I run it last year on some of my acres. I have a neighbor that's been running it for 3 years who really likes it. I'm looking at a product called Spectra that I'm going to get through Brad Faulkner that's got 5.7% chitin in it. But yeah, I went away from insecticides a couple years ago, and we've just been trying to play around with something different in furrow. And chitin seems to be the biggest player out there that we're seeing a response, a positive ROI on, and it's safe to handle is the biggest thing, you know?
Yeah. It's kind of cool to think because you're basically, what I'm assuming is happening is when you place, dead bugs into the ground, the crop takes that as a signal that it needs to begin to really boost its plant growth promoters. So it starts to respond, its response. We're assuming that the response is that the crop is picking up on that and seeing it as a potential threat. So they're improving the PGRs. So
see, I don't know what chitin does besides the fact that it's basically hard shell dead bugs and shrimp shell or whatever.
It's
that's all
really,
that I know. And they're like,
accessible.
yeah, it works to keep bugs away. And basically it's a really good insecticide, but it's safe to handle and whatnot. So
it's supposed to be really rich in polymer polysaccharides, so like longer chain, carbon and sugar molecules that are a really potentially good food source for kind of like Josh was saying, skipping right ahead to making those kind of plant growth promoting hormones, phytohormones, or osmoprotectants or whatever that could protect you against bugs. So it's kind of even similar to, like a fulvic or something that's a really nice carbon source, a really good balance of carbon and nitrogen, and a really good source for some of those microbes to run is my understanding for the chitosan products.
Yep.
Well, Ryan, if you want to do any more work with us, we'd love to run some more trials if you're wanting to test anything. One thing that we're trying to get into is to figure out, use these RIZE scores to look at different seed types. Different seeds, they perform. We're learning that based on the genetics of the soil, some seeds, they respond better to certain soil types. And so that might be something that if you have a question about which seed to use, we might be able to throw your mix on there and test the different seeds if that's something you're interested in.
Yeah, no, I'd be interested in doing some different stuff. I want to change up my in-furrow program to more, hold on, Kendrick, to more biological and keep any type of fertility maybe out of the furrow, and put it, next to it since we're running the nitrogen sulfur anyways. So I don't know. I'm open for whatever.
Okay. Sounds good. Well, I know that we're running over here. We can stay on and show some more reports if y'all are interested in seeing a little bit more data.
We
Keenan,
can
did
even
you
do it for
have-
the recording if we just want to do it for people who might jump on later. Get to, I think we have Olson and Ziegler infield reports that we could pull up,
Let's
and then
keep
we can
this
run
party
through a little
rolling.
bit more. All right, let's I'll pull up some more reports.
Thanks, Ryan. Appreciate that. Thanks for the insight there. I'd love to get that
Yep.
Yeah,
yield
that's
data
great.
too.
Not a problem.
You have available.
All right, so this is going to be Olson. These are actually, I mentioned this field earlier when I was pointing out some of the greenhouse data, where there was a till field that they very recently leased and a no-till field that they've been running for a while. And these are the infield rhizosphere results for that. The crops were at a little different stages, I believe, so that might kind of preference or skew it a little bit for a direct comparison, but it was definitely interesting to see that they were both actually pretty healthy soils. Again, like seeing a rice score above 5, a little bit more genera in the no-till soil, although we had, again, really quite high mycorrhizae and rare biosphere, especially for a soil that's had a pretty typical till regime. Really nice nitrogen cycling, good fixation, and especially for a corn crop, I do think it might have been rotating out of a soy rotation. I can't recall exactly, but so still really good nitrogen fixation, good phosphorus cycling, and yeah, no huge takeaways here. The differences weren't too significant, but did see, yeah, some pretty good results there. Do you have any insights here, Josh? I guess we'll have to kind of.
Well, I would say one thing that stands out to me is typically in a no-till system, you don't have as much denitrification. It's a marginal change. It's only 5% difference, but yeah, typically no-till is able to hold on to some of that nitrogen a little bit better, but might not have as much. I guess we have more nitrification occurring and a little bit less nitrogen fixation occurring. So, I mean, it's marginal. I would be really interested to see what that tissue sample came out to be if Hayden has any tissue samples from that time of the season, that would be really interesting to look at. To see if we're staying in that sufficiency range or if there's any major changes or shifts in that nitrogen. But yeah, I mean, I guess that's the case for all of these samples. We love to run tissue alongside of metagenomics data. We also run Haney's alongside metagenomic data. And essentially what we're doing is we're looking at the availability of the nutrients in the soil with the Haney. And then we're looking at, okay, are we seeing more microbial activity in the roots? If so, are we seeing better sufficiency ranges for the tissue? And so if there is if there is some sort of, maybe you have high levels of aluminum or high levels of zinc in the tissue, is there a certain pathway that might be disrupted, which is resulting in that? So how can we turn those nutrient pathways back on to help the crop get into sufficiency range is something that we've been doing a lot of work on this year.
Yep. I guess I'll just, unless you have anything more on this one, I'll jump into Ziegler. Also saw some interesting results there. Let's see. So yeah, this was, I'm probably sounding like a broken record at this point, but you're seeing a lot of fives and 5.5s and stuff on these. I just want to throw out there, we don't always see that this is, these are actually higher than what we see on average. So
That
yeah, I
Iowa
want to preface
soil,
that right away.
it's the Iowa soil is really, really good.
Yeah, we got a lot of really healthy looking results from these samplings and these trials. So yeah, this was there was an unterminated, I believe it was rye. It might have been a mix with like some triticale or something cover crop. And then the home field, which yeah, was maybe a couple week or month old soy that had I believe swine manure put down. And so yeah, actually the microbiology was really healthy in the home field, even post termination. So I think it speaks well to what the manure was able to provide, and especially over time, keeping that biology, healthy and ready so that when it does go through that burn down, it's not getting hit too hard. But again, this cover crop looks really nice too. Love to see all that nitrogen fixation coming from a cover crop, or occurring in the soil of cover crop. And I always love to see these nitrogen values trending together, right? All across, whether, obviously we like the nitrogen fixation most, that's going to be adding nitrogen to your soil, but it's definitely healthy to have all different forms of nitrogen, the nitrates and the nitrites and all that stuff, for different biological functions, for different plant functions. So like to see that high polymer degradation, drought resistance, a little more disturbance in the home field. I think that tracks for this one because again, it had been more recently terminated. And you might expect that once you terminate this cover crop, this disturbance value would go up a little bit. Interesting difference in the fungal bacterial ratio. It was much, much lower in the cover crop than the home field, which is interesting because it had obviously experienced some disturbance. I don't remember exactly if it was like strip till. I don't quite recall, but a really good fungal population in the home field. So again, I think speaking well of the manure that was put down in the regime that they have there, as far as putting that manure down every year and that boosting those fungal populations over time. But again, yeah, also high mycorrhizae and high rare biosphere in the cover crop, in the unterminated cover crop as well. You have any thoughts on that, Josh?
No, I'm trying to recall, was the home field a noticeably, better field than the Oak Fisher? I don't recall.
That one was tough because the home field, I think those soybeans were only 2-3 weeks old. I think there was like V2, V3.
Yeah,
And so it was a little hard to judge that compared. I mean, the cover crop definitely looked healthy. It was a nice tall cover crop, and I think that they were just having to wait until all that rain that was going through passed a little bit before they were able to get a chance and get in there and work that field in the spring. So
and we didn't actually pull rhizospheres. This is a core sample. Do you recall?
I thought I guess maybe for the
No, we did. I'm sorry. I'm just trying to refresh my memory here.
no, me too. You got me thinking. I'm pretty sure that I know that these soybean rhizospheres, and I thought we had tried for the cover crop as well, but I can look back at my notes to try and make sure. So
Wow.
I think okay, we're close to the end of these. Make sure I don't see my screen right. All right, so this we had labeled as bad and good. This was at Nathan Moretz's farm. There was one area that kind of similar to some other farms, they're, had recently acquired or rented from another farmer and had experienced kind of traditional tillage, and a farm that I think they did kind of a strip till out there. Apologize if I'm way off on that, but and had been putting their cattle manure, their cow manure down on that good field for quite a while, and it did show a higher rise score. Again, I think only by about 0.1 or a little more than that, but actually I was really surprised at how well this field that we had labeled bad, the kind of conventional management field, performed. It actually had really good mycorrhizae, really good fungal populations overall. Performs a little bit less well on some of the nutrient functions. So that's one thing that's kind of interesting, is that manure is promoting good nutrient cycling, whether it's just, has some NPK in there and that's, feeding the microbiology, or that OM in there is allowing the biology to feed a little bit, more efficiently, to grow and to be able to move those nutrients around. But really high nitrogen and phosphorus cycling in the manure sample, but a really good result for this tillage sample as well. And these were, trying to think, I think these this tillage sample, the crops were a little older, so that could factor in here as well. I think these the manure samples were only a few weeks old, and the conventional samples were maybe V5, V6, if that sounds right to Josh. And so that could also, add a little bump in the score versus the manure sample, but really good responses for both, or really good samples for both, and I think some
Look at
interesting
that.
differences to look at.
Look at that disturbance.
Yeah, that's a great catch there, Josh.
That just really sticks out to me. That one bad tillage area. Disturbance is essentially a measurement of the size and the maturity of the genome, which so if you have smaller, the way that I like to describe it is, if you have smaller DNA, that DNA is able to serve functions more easily, so they can integrate into more complex systems. That DNA can copy and redistribute and colonize quicker. Versus whenever you're tilling, what you're doing is you're breaking down these complex systems, and the DNA is becoming more longer, so it's not easily able to communicate with other microbes in the community. And so that's how we were able to pick up on the disturbance. And I think this is a great example of, okay, if you're tilling, are we going to see higher levels of disturbance? Are those communities going to be more mature, or are they going to be less mature? Which I think is what we're seeing here in this sample. Awesome. Well,
Yeah.
I think that's it. If anyone has any questions, please don't hesitate to reach out and give us a call. We'd love to sit down and just kind of go over these results one-on-one and individually review the data, answer any questions. But yeah, this has been exciting, and we're learning so much from these trials. So thank you guys so much for opening up your doors for us to come out, pull samples. We're going to continue to improve our analysis and our ability to predict and help make decisions on what sort of biological decisions to make out in the field.
Yeah.
So guys, I'm just here at my desk now, but when I had that initial yield data up when we first started the call, were you able to pull off of that, I guess, the difference between the two, the treated and untreated?
I don't know that I don't know that.
I was trying to write it down, but I
Okay,
didn't
so
quite get
I've
it.
got it. So it ended up being the untreated, never had organics, had an average of 192.25. And then the organics treated was 198.77 on average. And that was a 6.52 bushel difference.
And
So we had
thanks
a
for running that math for us. This, like Josh was, I think, pointing to, this is really great data for us. So really helps
And
us
that was a,
understand.
you know, that just pulled yield data. I'd say over half of those planter passes because it was half width, but basically we had 3.889 acres on the one and 3.878 on the other. So I mean, basically identical, you know, in total area.
Yeah.
But it would have been 3 half-mile passes, 20-foot wide, short half mile, I guess, because of the building site.
That's amazing. So it was a 6, you said it was a 6 bushel change.
6.5.
Our rise response was 0.09. So that kind of falls in line with that
Yeah.
assumption that we can expect around a, you know, I think it was a 3 to 6 bushel change for every 0.1 adjustment in the rise score. So
So we correlated well then.
yeah,
So
it's really good, strong correlation there.
So, and I think I mentioned before, the big thing, I guess, is I'm looking forward to next year where I'm very interested in, which we would have done this year, is really a comparison, pulling out that organics where it's had it for now 3 years.
Wow. Yeah.
You know, and
see how it drops off over time.
Yeah, see if that response, now that it's been treated for 3 years in a row, stays at the same level, or if that response falls off. You know, it's
I'd
one
be
thing
very
for a
interested to
farm
see.
that's never been treated before, but I guess, you know, we're hoping as we engage in these practices and the different biology and bring that and introduce it to build a healthier soil environment, that maybe we get to a point where we don't need these products year after year, or we find the next one.
Yeah.
So that's what I'm looking forward to doing next year anyway, because this will be corn again. So I can utilize those 4 check passes that I've never had again, potentially.
Awesome. That sounds good. Thank you for pulling that data. I know it's not easy, but definitely really helpful for us in this analysis. So
Yeah, and we'll be getting that down to the ag launch team and stuff so that they can slice it out better anyway, and you can get sliced down to right where we took those samples anyway as well.
yeah. Keenan, or what was those numbers again? So it was 192 for the untreated, and then
192 and 198.7.
98.7. Got it.
Yep.
Awesome.
And I can email this to you guys here this morning, just this report anyway. So as a first level.
Excellent. Cool deal. Well, have a wonderful rest of your day. Thank you for your time. It's good to reconnect with you, Joe, as always.
No, this was enjoyable, and yeah, I'm still really wishing I would have spent more time in agronomy classes.